This section's on 3.5, solving equations and inequalities with absolute values. So with absolute values, they're going to look something like this, and I'm sure most of us have seen an absolute value. And we're going to say it's an absolute value of x is equal to a. It's the same as having, and then you're going to split up two parts. So when we learn something like this, pretty much like early on, we learned that if anything is inside the absolute value, there's two values of it. So if I had, like, for example, an absolute value of -3, I actually have is a +3, because when it comes out of the absolute value, it is positive. So technically, you have two parts. You can have inside the absolute value a positive or a negative number on that. Okay, so now graphically, let's take that now, idea, and do example 1, where it takes this equation, an absolute value of x is equal to 5. So an absolute value is a V shape, which is like this right here, and it starts at the vertex of 0. And what you want to do then is, when we say it equals 5, we're saying that there's actually two parts of the equation. This is one part of the equation, y equals the absolute value of x, and then the other equation is y equals 5. So now y equals 5 is a linear equation, which is something like this at the red line right there. And we're trying to find out is where do they cross right there and right there of the x value right there. Okay, so that's the idea when we compare two parts like this, and we're trying to figure out is graphically where does it fall in. So then let's go ahead and take example 2. So example 2 says solve the absolute value of x minus 3 minus 1 is equal to 4. So whenever we're working with absolute values, similar to what we did in the last section when we had the square roots, you do not want to have a value after the absolute value nor before it. Okay, so just like the square root, you want to get rid of those and just have the absolute value by itself, so then you're going to work that problem out. Now, we mentioned before also, if you work the opposite of the PEMDAS, that's going to help us then define is the solving for x. So whenever you're solving for x, something like this, where you have multi-steps, I would always say go backwards on the PEMDAS. So look for any adding and subtracting if you can. If there's no adding and subtracting, look for multiplication or division. And if there isn't, then look for exponents or parentheses. So the first step is adding and subtracting. I'm looking at this. There's an adding subtracting part right there. So I want to get rid of that right there. So the opposite is what we do. So the opposite of -1 is +1. So we're going to go ahead and add 1 on both sides right there. So that leaves me then the absolute value of x minus 3 and then equals 5. Okay. Now again, going back to the example 1 right there, we said, or actually the notes up here, we said that there's two parts of the answers. So similar to that, we need to actually split this up and make it into two parts. So one of the parts that we need to have is then absolute value of x minus 3 is equal to +5, right? Because we said it will be +5. But then the other one is going to be a negative. So then absolute value of -3 is equal to 5. And I usually put a negative in front of the absolute value right there, because then we want to know is it positive and negative. So there's two parts of the answers that you need to work out on this one. Okay. So the first part right here, once it's going into this format, you don't have any multiplication or division that you have to work this out. So it's pretty much ready to go. So I'm going to drop my absolute value, and I'm going to go ahead and solve for it. So I drop my absolute value, we get something like this. We're going to add 3 on both sides. X equals 8 is one of the answers right there. Okay. Then the other answer that we want on this one right here is to divide by -1 on both sides. So I'm going to keep this for right now so I can get rid of that, and we get -5. Now if I have any adding or subtracting or multiplication involved, then I continue to do that, but I don't, so then I can continue to drop my absolute values and solve the problem. So then we want to add 3 on both sides, right? Add 3, and then x is equal to -2. Okay. So then those become your two answers right there. Now, when it's an equal sign, then you're going to continue on the problem and just say that those are the answers right there. Okay, So that's one type of problem that you'll do. The other type of problem you'll do is inequality signs. So the inequality looks something like this, where you have this greater than and less than symbol right here. Okay, so then we're saying that this absolute value right here is less than 5, and we're trying to figure out where is that statement true. So we want to do the similar idea as what we just did in example 2. We want to go ahead and solve it. We're going to split it up into 2 parts and then continue to solve it. So let's go ahead and split that up. So then again, right here I have as 3x plus 2 is less than 5. And then the other one I have is 3x plus 2 is less than 5. But I'm going to go ahead and put a negative right there. Okay? So again, I want to make sure I have nothing to add or subtract, because we're going to go the opposite of PEMDAS. I have nothing to multiply or divide outside here. So if I'm ready to go, I'm going to drop my absolute values. And we're going to have 3x plus 2 is less than 5. And I continue to do my algebraic steps. So I have to get rid of 2. So we're going to go ahead and subtract it. So 5 minus 2 is 3. And then x is less than 1. Okay? Same thing with this one. So if I have a negative right here, so we're going to bring it to the other side. I have is absolute value of 3x plus 2, and then we have is a negative 5. Now I also want to introduce for the inequality sign right here, only for the inequality, because obviously on the equal sign it's not going to change anything. But when you divide by a negative right here, you always have to flip the signs right there. Okay, so the sign's going to flip this direction because I divided by a negative 1 right here. Okay. Now again, I don't have anything behind it or in front of it, so now I can drop my absolute value, continue on with the problem, greater than negative 5. So we're going to go ahead and subtract it. Now this is where a lot of students will get confused, because just because you subtract the problem does not mean you're flipping the sign again. It's only when you divide by a negative that you flip the sign right here. So if I subtract it, it's still going to become greater than right there. And then negative 5 minus 2 gives me negative 7 right there. Okay? Then we divide by 3 on both sides. So since 3 is still positive, that means I would still continue my greater than symbol right here. 7 over 3 like that. Okay? So I have then our 2 answers. One is x equals 1 right here. And x equals or greater than negative 7. And the other one was x is less than 1. So we need to graph this on a number line and then find our final answer. So when we have is 1, I'm going to go ahead and do a little sketch right here. So at 1 is right here, and then I have is negative 7/3. So negative 7/3 is somewhere on this side. Obviously it's after the 0 mark right here. It's on the left side of 0. Okay. So when we do this kind of graph, we read it as x is less than. So we always read from the variable to the number. I know people get confused because sometimes this flips over and it goes something like this, and then people get confused. So you always read from the variable to the number. So it doesn't matter which direction it is, you just start with the variable. So if this variable is right here, we say x is, and this is a closed mouth right there. So it has to be less than. If it was the opposite direction like this with the open mouth, we would say x is greater than 1 because it's an open mouth. Okay? So going this direction, since the variable is right here going to the number, it has to be then x is less than 1, because again, less than is going to be then on the left-hand side. So from this graph right here, on 1 right here, we're going to go less than. Now also the inequality sign, you have to pay attention right here, since this is just less than, so anything that's less than or greater than, then you have is an open circle. If it's less than or equal to, which is then usually the little line underneath it, or greater than or equal to on the line underneath it, then it would be a solid dot right there. But since it's not, we're going to go ahead and have an open circle. So again, it was x is less than 1. So less than from this direction is going to go towards the left side. So we're going to go ahead and graph that way. Okay. Next one is then x is, what is that? Greater than, right, because it's an open mouth right there, greater than negative 7/3. So here we have again 7/3, It's that less than symbol, so I just have an open circle. And we said x is greater than, because it's an open mouth right there. So greater than would have to be on the right-hand side. So everything on this side right here. So our solution is where the two graphs meet at. So the graph meets right here at this spot right there. And it cuts it off right there. So that's where the meeting happens right there. Okay? So since that's the final meeting part right there, we're going to go ahead and write the final solution. So I'm going to show like two ways to do this because it could be either one. So you can write it as between -7, 3, and 1. So this is similar to what we just did on the domain and the range. Notice it's parentheses because it's an open circle on these guys right there. Okay, so if it was a closed circle, then you can go ahead and do the brackets like we did on the last section. Now, you could write it like this, or you can say x is between, right, because x is between -7/3 and +1. So you can write it the inequality symbol right here, or you can write it with the parentheses and brackets like we did with the range and domain. Okay, so either one is correct. I don't mind which way you do that part right there. Okay, the last example, example 4, we have then is absolute value of 5 minus 2x is greater than or equal to 1. All right, so we want to split that up again. So I have is then again 5 minus 2x is greater than or equal to 1. And the other one, we're going to put a negative on the outside right here. Minus 2x is greater than or equal to 1. Okay? So again, I don't have anything right here. We're good to go. I don't have anything right here. It's kind of like the square root and the radicals. You don't want anything on the outside of the radicals or in front of the radicals. So it's the same idea right there. So then we can drop our absolute value and then continue the problem right there. So then I would have to get rid of is the 5, right? Because it's the opposite of PEMDAS. We're adding, subtracting. Because again, variable is what we leave it at the end. Because that's what we want to solve for. So it's positive 5 right now, so we have to subtract 5 on both sides. So then I have is negative 2x is greater than or equal to, so negative 5 plus 1 is negative 4. And then we have to divide both sides by a negative 2. So we said before, if you divide by a negative, then you have to flip your inequality sign. So it goes this direction now. So 4 divided by 2 is 2. Okay, so that's one answer right there. Next one. We're going to go ahead and divide, because again, I don't have anything back here, but this is a multiplication or division. Technically, it's a -1 right here. So if I'm dividing by a negative, what happens to that? Right, we need to flip the inequality sign. So we flip it right there, and we go -1. Okay, so now I'm ready to drop my absolute value. So we drop the absolute value, and we continue with the algebra. So again, we're going to get rid of 5 by subtracting 5 on both sides. Subtract 5. We have then is negative 2x is less than or equal to negative 6, right? But what happens next? I have to divide by a negative 2 on both sides. So then x is greater than or equal to 3. So I did a little somersault right here because it flipped back and forth on that one. Okay, so just pay attention to that one, the inequality sign, because it will make a difference on your final answer for this. Okay, so we have between 2 and 3 are the solution. So on the number line, I'm just going to go 2 and 3. So we said x is, what is that? Reading from the variable to the number, x is less than, because it's a closed mouth right there, less than or equal to 2. So from here, less than or equal to is a closed circle. Less than is going towards this direction, right, to the left. And then we have then is x is greater than or equal to 3. So it's greater than or equal to. So again, 3 is closed circle. Greater than or equal to would have to be on the right-hand side, this direction. So what happens is the solution's all of this right here and also all of this, which means it's not the same as this one right here, because this one overlapped right there, right? Whereas this one right here, they're actually going opposite direction. It's like a negative and positive, or they're repelling against each other. So again, there's two ways to write this. So one of the ways, like the domain and range, we can say it's going from negative infinity, right, to 2 with a bracket right there, because it's closed circle right there. And then I'm going to introduce this thing called the union. This is the same thing as saying and. In mathematically, that's just saying like the same thing as and. And then we have as a bracket 3 to positive infinity. So that's one way to write it, just like how we did with the domain and range. The other way to write it is the inequality sign. So the inequality, you'll probably have to split that up. You have to say then x is less than 2, less than or equal to. And then you can do and, I guess we'll have to spell it out, and x is greater than or equal to 3. So there's two ways to do that one. This one, again, we can't put it just like how we did with this one, because on this one, if it intersects in the middle, we can say that they share, that x shares, or it's in between these numbers right here. But this right here, since x is not between it, it's going opposites on end of each other. We're going to have to write it up this way right there. Okay? So that is the lesson for 3.5.